Welcome to 2023 question A-1. So the image on the right shows a tissue box. The opening at the top of the box is elliptical in plan. So that telling us this is elliptical. The drawing below shows a plan, an incomplete elevation, and end view of a similar tissue box. Position of surface development, surface A, is also shown. So our surface A, I've got it ready to go first. First off, they want us to complete the elevation. So what's missing from the elevation is this freehand curve here, represented by the elliptical curve. So what I'm going to do is I'm going to find some points along the way here. So looking at this 30 total, so just to make it nice and easy, I'm going to divide this up 5, 5, 5, and those will be my divisions. I'll project them up. And that has given me these points around the outside of my object, of my tissue box. Okay. What I'm going to do is I'm going to project them to my elevation, or to my end elevation, because that's an edge view. So if I project up this point, or this, I'll find the point on the edge, and I can bring it across then to match up. So I'll project all of these across. These points are quite close together. That's fine, we just have to be accurate. Just realizing there's no real point in bringing the back portion because it's symmetrical. We can see from a line of symmetry there, so no need for that. But yeah. Okay, so let's start with our first point representing here. So I'll bring that across and match it to the center. So that's my first point. Next, then I've got 1, 2 points. I'm going to draw it up onto the edge. Sadly, there and there. And finally, I've got that point join it to these 2 points. Okay, so I can draw my freehand curve now. So that's the elevation of my tissue box. Okay. Now they want us to complete a one-piece surface development of surfaces A and B. So we'll start with surface A. Surface A is this front portion. Okay. They've given us RS. Let me just double check that that's the same length. I'm sure it is because they've got a line of symmetry there. Yep, same length there. Okay, so I've got my base, I've got that line already. Alright, so what we need is we need the length of this side and this side next. Okay, in our end elevation, we've got an edge view of that surface. Okay, we're seeing an edge view of that. So we got the true length of it there. So I could rotate it in plan. Okay, and look at it perpendicularly, but there's no need. I've got that distance here. Okay, so that's going to be the height. Okay, so that's the height. Okay, I've taken it from there, stepped off. All right. Next, we want to find how wide the top is, which when we're looking down in plan, this is a horizontal line, so when we look down in plan, we see it as its true length. So I can actually, because I've got my line of symmetry here, take that distance there and step it off either side. Okay, so that's some of our development completed. All right. Next up, we want to draw this curve. Okay, so the curve is going to be in here. Curve starts at this width. Okay, which we actually said was 15, isn't it? Yeah. Now you could get that distance on your compass and step it off, but I know it's 15. The whole thing's 30. So I'll do that. And I divided this up using 5, so I'm going to use those points again. Alright, so shift these down and leave them for points. So those points here, right, those are the corresponding points, and we found them up here. So the true length from the top down to each one of those points I can take here and step off. So we'll start, it's my outside, we're going in 1, so that's going to be to this distance. So I've got that distance on my compass, and I can swing an arc. It's all about, these development questions are all about identifying where are the true lengths. Okay, so next I'm going to find the next marker, which is there. That distance, and I can step that off. Next point, the next line, and then finally we've got the outside one, the lowest down one there, and I can step that off along the line of symmetry. Okay, so I've got my free-end curve then. Heavier. Okay, now go around the outside. Heavy also. Okay, so that's A, right? Now we need to find B. So that's this triangle here on the side. Okay, we've got one edge of it, so we've got this edge of it. We need to find the base and the opposite edge. So base, the true length of that line, we'll see when we look down and plan, because that's a horizontal line. It's resting on the XY line. That's a point view. That's the true length of it, looking straight down on top of it. So I'm going to get the distance to the base of that triangle from my plan. I can swing an arc from S out here somewhere. Then the opposite side, this length here, is the same as this length, okay, which is gotten down here, right? We're actually, now that I think about it, we're just drawing this triangle, are we? Or we're not, because that's sloping away from us. So I get the length here. Swing arc. And now I can join there, there, and we've got our fold line. So, okay, so that's A and that's B. Right. Surface development completed.